In this series of videos, we're going to talk about inverse functions, and before we get into that though, we kind of want to define what an inverse function is. So we're going to go back and we're going to look at this picture of a parabola. This is the graph y is equal to x squared. Now, we learned previously that we can tell whether or not something was a function by doing the vertical line test. Remember what that was? It said that if I take a vertical line, draw it across my graph, and if it only touches it in one place, then this is considered a function. So we can then take functions and go one step further and talk about a function being one-to-one. So if I have a function that is one-to-one, we can see over here, let's go look at these points. These 4 points are points that would be on the function that I have over here. You can see that we have a -2, 4, and a +2, 4. We're going to learn that if I have a one-to-one function, all I do is replace the x's and the y's. I switch their positions in the ordered pair, and if it is one-to-one, then it is indeed a function. So let's go down here, and if we switch the x and the y values in these ordered pairs, this new set of ordered pairs should also be a function. Now, we want to go back and we want to remember, if I'm looking at just ordered pairs here then, that these two ordered pairs in this center part right here just threw this set of ordered pairs out of actually being a function. In other words, my highlighted yellow terms here are not considered a function because, remember, we want one x for each y. Here I have an x of 1 and another x of 1, and you can see that when I put a value in for x, I'm supposed to know what that value is coming out for y, and I don't have that happening here. So if I were to switch the x and y components of my parabola, of my known function, into the yellow parts that I've highlighted here, I'm creating something that is not a function, and that's not really what we want. So what we would say then is, although this is a function, this is not considered one-to-one. Okay, so we can be a function but not one-to-one. Now let's go down here. Rather than looking at the ordered pairs to determine whether or not something is a function, we can do another one of those line tests. And this is where we have the horizontal line test. So I know, first of all, that this y equals x cubed is a function because I can pass a vertical line across it and it does only touch my function at one point. I can go one step further and test for now if it's a function, is it one-to-one? And I can see that if I pass a horizontal line across my graph, it only touches the graph at one point. So this is the horizontal line test, is the test to determine, horizontal, is the test to determine if a function is then one-to-one. And we can see that if I go back up here to my parabola, which we already kind of said isn't one-to-one, and we showed that using the ordered pairs, but watch what happens if I draw a horizontal line across this. You'll see that my horizontal line touches the graph in more than 2 places, and so we can apply the horizontal line test to determine whether or not a function is then one-to-one. So this is how we're visually looking at it. Once we've determined visually, or if we determine visually that something is one-to-one, even if not, I wanted to describe then, if you know that a function is one-to-one, then it has these 2 sets of characteristics. Okay, so this is a set of definitions I want you to understand. If a function is considered one-to-one, then it has an inverse function, f inverse. And that is so key for what we're going to do in some future math here. So if a function is indeed one-to-one, then it's going to have an inverse function. So the domain of my function becomes the range of my inverse, and the range of my function becomes the domain of the inverse. Notice that the ideas here are switched, right? Okay, so this is going to be key for us. And the second characteristic we want to think about is if it is a function, if a function is one-to-one and it has an inverse, then if we compose the two functions together, we should get back just x, what was inside. So if we compose them together, we should just get back x. Okay, and it must work in both directions. So I would have to compose f with f inverse to get back x, and then go in the opposite direction. F inverse of f of x must also be equal to x. Remember that composition functions are not normally commutative. You can't just do one and assume the other direction always works. But if the function is one-to-one and they are inverses of each other, then it does give you back this x value here. So this is what we're going to be talking about when we are dealing with the rest of these videos on inverse functions.